Hello everybody, I hope you're okay. I've got to build a diagram of how APNS works to explain it to somebody later on in the week. So I thought I'd film it and I thought I'd show you guys how it works, so in case there's somebody out there who doesn't get it. So APNS, or Apple Push Notification System, is the way you send notifications to iOS apps and iOS on the web. We're going to be looking at the diagram and especially one case in which the standard workflow does not happen. So let's jump over to the computer now. Okay, so we've got the three things in APNS. We've got Apple's servers. This is what the device communicates for getting the tokens and what we're going to be sending the request via. Of course, the obvious one is we have the device. Let's make that a different color. Let's go with blue for the device. Let's go with orange for the server. The other thing we need in this situation is the app server. So whatever server you're developing and running your code on, whether that be like AWS or Firebase, something like that, doesn't really matter. It doesn't matter what it is. It could be Lambda. You just need a thing that you can send the notification token to that can then exchange it and then send the push notification when you need to. I'll explain in a minute. So these are the three key areas that are important. So you've got the device. So on the device, what you'll have is you'll have the iOS application that the user is using. You request to the system that you want to be able to send push notifications. And what this does in step one is go from the device. We'll indicate this in red. We'll go from the device to Apple servers and we'll say once push. You want push. You want to be able to send the push notifications to the device. So you're requesting a push token. The server then sends back to the device the push token and what that might be. Say that's AAAA, BBBB. Simple, so like, it's normally quite a long string, and they send it back to you in a byte array that you then have to convert, I'm pretty sure. So that goes back to the device, and then that is sent into the application that you run. So now what we're doing is we're sending the push token from the device and the application, your application, to your server. However you want to do this is up to you. Normally I use like JSON and just a HTTP request, that normally does it. There is the possibility that this token can change. As far as I'm aware, this doesn't happen often. It mainly happens if the device is changed, e.g. the app goes from one device to another and you're keeping the same user account and session data, the token will change, or for some sort of update to the system, it can request a new token. But there is possibility in the future that this should change. So this is not a one-time operation. It should be able to be done more than once. And then what happens is if you want to send a push notification to that device, your server sends a request to Apple. So we'll indicate that in a different color. Let's go with this purple. What happens is your server sends a request to Apple saying token AAA BBB hi. That's massively simplified that, but essentially you're going to send the token to Apple as well as the message that you want to send to the application. Normally this is in a required structure of JSON with some keys that are required, and you have to specify things in order for the system to handle it differently. So what happens is then Apple servers, they think about this request for a little bit. They have a bit of a think about what they should do. If you say that it's transactional, it'll be sent to the device as soon as possible. If you say it's promotional, it'll be sent at the time at which the device next does like an update of promotional information. So if you're sending marketing, you're supposed to set it to be promotional, whereas if you're sending something that's transactional, like an alert, say your order has been delayed, or something like that, send it as transactional. So what happens now is the device gets sent the request. So we're going to send that message that the server sent to APNS to the device. There are now two different things that can happen. Number one, APNS shows the user a message. APNS directly presents the message on the lock screen or as a push notification to the user. There are actually three things I've just realized. Two, APNS sends it to your app's content extension. This only happens if you set the content mutable key to number one, e.g. there is content in this notification that the app might be able to provide additional information and update for. You might say do this in WhatsApp where the content is encrypted and the keys are only on the device. The keys aren't held by the server, so the server can't decrypt it. The device needs to decrypt the message in order to be able to show it to the user with valid text. And the third situation I've just thought about is APNS delivers it to your app in the background. This is essentially you saying that there is no presentable text in the notification and that it's just an update for the application to maybe say download new content, change this or change that, whatever it might be. this doesn't get shown to the user and can't get shown to the user. This always goes to user. The same with this. There is no way that a notification that is user presentable, once it has arrived on the device, cannot be shown to the user. The only thing that won't get shown to the user is a background notification, but they are only delivered to the app when the system deems it is important. There is a limit to the amount of these notifications that you can deliver a day. If you send more, the system just won't load your application, and your application must say if it worked or failed. E.g., you have to return back that you downloaded something, you did something, or it failed, you had an issue, so that the system understands. But this is a standard workflow. This also works for the web. You have your application and you do the same thing, other than the fact that you have a bit more control over the push token, and you always get to run some code when it's received on device before it's shown to the user. There is one exception to this rule. The problem with this situation here is that it requires Apple's APNS server to be contactable all the time. So in the event that there is an issue here in this line, and for whatever reason, the device cannot talk to Apple's servers, that might be because you're on an air-gapped network, like a cruise ship or something like this. Shockingly enough, most of the cruise ships I've been on don't implement the feature that is designed directly for them. In this situation, you can register something known as a local push connectivity extension in your application. So what this is a little bit of code that runs on the client's device that actually interprets and does all of the sort of stuff Apple's servers do, but with your server. So this is a small, lightweight application which is local push. The way this works is, instead of you requesting Apple's server notification, you request local push connectivity. E.g., you just want the app itself to be able to send push notifications to the user. You then register this extension with the system. So this goes over here to the system, and when you're registering this with the system, you say SSID, I don't know, the network. And what this means is only when you're on this network, the network that you've specified, you can specify more than one, will this extension be loaded. This extension is automatically loaded by the system so that it's not running all the time and is only running when it needs to be run and when there's no public internet access or when you've determined it to. So what happens now is your local push server goes out to your local server, to your server instance, probably by something like WebSocket or HTTP to one-way traffic, so that you can send requests from the server directly to your local push extension. So like you did previously where you went from here to here, you're now going to go from here to the local push extension on your device. And this can be in whatever format you want it to be. Most of the time when I do this, I implement a standard format similar to how I send to Apple servers, so that it's the same and it's not that complicated. And then what happens here is this local push server has the job of sending it to the device system via something like local notifications. And this is presented to the user however you normally do it. Of course, you can handle background notifications and stuff like that. You can handle it however you want in this case. But this case only runs under a certain set of limited circumstances. There is possibility for the system, when it's in low power mode or running out of power, to shut down your local push extension and require you to use Apple servers. Apple advise that you always try to work out if you can use Apple servers first before you use your local push connectivity extension. However, they have introduced this to allow you to be able to do this in this situation. And that, as far as I'm aware, is the only exception to the rule. And that's kind of how APNS works. It's a bit of a there. But the main three parts are your server, the device, and Apple servers. Get the token from the device, which comes from Apple servers, send it to your server, from your server to Apple server, back to the device to send the notification. If the device is not connected to the internet, you can register a local push connectivity extension that can connect directly to your servers that might be local. If you're on, say, a cruise ship, you might not have internet access publicly, but your server might be on the ship itself, and then it can send directly from your server to the device. Simples. Speeding up the process, reducing the bandwidth. And that's kind of how that works. I hope you found this interesting, and I'll see you in the next one. Goodbye!